Hello, we are still with this interesting book, and we want to explore the just two equations of the four. I want to just to comment, to give some comment. Now, it would be really interesting to calculate this value, but the first two equations actually aren't about this one. You may check the previous video I made about the whole convention used in the book, and we will actually the writer defined the error. Now that error is something that can be calculated, and is something that we can know its formula, and it's related. Now this error actually is the is the partial derivative of the cost over z. I don't know what to call z, but this is z over z. For example, if we're saying like the error of z of the neuron z in the layer L, so it's partial derivative of the cost over z, and again L, and did I say z? I should have said j of the neuron of neuron j. For example, this one, but here should be called L, not L plus 1. Big deal. Now, actually, we are pretty much interested in knowing all these values because from this delta, I guess from the third or fourth equation, I guess we are going to see how to relate this error to the partial derivative of c over the weights and biases for the same J neuron. Okay, for the same J neuron of the L layer. Now let's go ahead and check the third equation, BP3. BP means backpropagation 3. Yeah, that's it. No, but it's right to a bias of the cost with respect to any bias in the network. Is exactly equal to the rate of, and this is great news. Oh wow, really, this is a great news. It's the same value. Wow. And then I think the PP4, yes, the PP4 is related to this to the weight. Now I'm just going to check with you the first and the second. Actually, this is the first. So what is it about? Again, let us just remember what was the cost function cx. Cx is just for simplicity, it's called c, and c is actually this is the quadratic cost, but c is just a function this is just a function of a1l and a2l. Okay, so we can consider it, and these two can be considered as two variables, and I think it's not wrong to consider them as independent variables, because really each one can be considered as a function. For example, a1l is related to z. It's sigma z1l, sigmoid function. For example, z1l, and z1l is somewhat independent of z2l. Okay, so c can be considered as a function of a1l. Now l is the final layer, it's the output layer, and no, sorry, it's like comma, and this is the first variable and this is the second variable. Okay, so it's a function of the two. So when we are interested in say the partial derivative of c over z we are talking about the final layer, and one, for example, it's only one or two. So now, how to deal with this? Actually, it's a little bit intuitive to say that A1L times A1L over A Z1L. Now, this thing, we know this function. This is like the derivative of sigma with the input Z1L times over A1L. Now, this thing is easily computed. We know the sigma, we know its derivative, we know Z1L. Z1L can be computed from the whole neural network, we know its value. So this is easily computed. Now this is computed from us by knowing the expression of the cost function. Okay, from the expression, we know that the derivative would be, this is the expression of the cost function, and this is the expression of the partial derivative of c over a1l, for example. We know it, and here it's really intuitive, and it's really much meaningful. And this is the backpropagation one, and this is the same as the backpropagation one. This is actually the variable, the vector. It's a vector whose of which the first term is like this one for J1, and the second term for J2, third term J3, and that's it. This is a vector, or the column vector. You can consider it as a column vector. This is a very intuitive product, and we multiply term by term, term by term, term by term, and we obtain a vector. And we know all this. This is about the backpropagation one. Now the backpropagation two actually is, now this is like just a not really interesting. The interesting part is this one. This is like for our special case where the cost is a quadratic function. So we have to, now this is the backpropagation too. I want to discuss this one. It's really interesting. Now back to this really annoying image. Now say we have for all these W's, W are the weights of this matrix, and these are the weights of index L plus 1, like the incoming weights affecting the layer of index L plus 1. Now, if you think well, for example, this from this K neuron, for example, WNK, WJK, W1K, W2K, W3K, W4K. When you say when you think of the cost function, the cost function is not only just is not only considered as a function of A1L, A2L. It can be considered as a function of W. I hope I'm not mistaken. Of W, or let me say Z actually. No, Z is a lot better than W. Z of Yes, the z here and the z here and the z here and the z here and the z here. Now we are relating this backpropagation 2 equation relates level L with level L plus 1, two successive levels. It relates two successive levels together. So the cost function is a function of zl plus 1, like this. A cost function is a function of z l plus 1 and 1, like the first neuron in the first neuron here, the output, almost the output, without applying the sigmoid function. And it's a function of z 2 l plus 1 and z 3 l plus 1 and zj l plus 1 and zn l plus 1. This is fair enough. Now what about the layer of l plus 2, which lies here? Shouldn't see the cost be a function of this one? Well, it can be, but we are going to get to consider all these, because all these will be a listen. We want to compute we want to compute we want to compute this, and I would like to say k, not j. We want to compute the partial derivative of the cost over the output value, the output of the neuron k in the layer L. Okay. Now, for this reason, we know that this we know that the cost is a function of all these z's here. Now, z's here are related to the a, or actually the a here is affecting the z here and here and here and here. So the z here is a function of this a, and the z here is a function of this a, and the z here is a function of this a, and the z here is a function of this a. Okay. And I don't know if you are familiar with this formula, like delta c. Delta is like is the, I don't know what you call it, differential. It's like, for example, it can be considered as c1 c of l, I don't know, c after changing minus c before changing. Yeah, it's a difference between two values of like your step of c. It can be considered as a step of c. Now this formula is not so bad, and c, we have agreed that c is a function of all these guys, here. Okay, so it can be written like this. Now after that, let us tweak it a little. Let us divide by this a l k, and let us change this to partial, and we divide by the same value, a l k, a l k, a l k. Now that's interesting. Now am I doing something wrong? Okay, now we are relating the partial, the error here, for example, the error here with all the errors here. Now, I'm not very comfortable with this partial derivative of z over a. I would be more comfortable if it's a over z. Anyway, over z, so over a, and then times a over z. But that would be a l plus 1. Okay, that's a lot better. And z over a, okay. Actually, I think I made a mistake. I should be. Oh no, no, it's fine. Z1 L plus 1 over. Oh no, because it's ZL plus 1 over A L K. No, it's fine. Uh, okay, what is this value? What is this value? L plus 1, and you are making a derivative over A L K. Now what would be the value? It would be this value. Okay, so this is equal to the weight L plus 1, the weight L plus 1 of from K to from K to 1, from K to 1, and this is equal to WL plus 1 from K to 2, and this is equal to the weight L plus 1 from K oh, K is not, it's not a good value. A L K L K L K. I don't want K here. I prefer J. I would prefer J, from K to J. Okay, from K to J, a lot better. So okay, now the expression is about to come to be life, and now this is omega L plus 1, K1, K2, Kj, etc., Kn finally, plus C over Z L plus 1 N, because yes, actually yes, that's true, and the weight from of course it's L plus 1, that is from K to N, from K to N, and K. Okay, now considering this matrix, we transpose it, and we multiply it by by this guy here, by a vector, and that vector is so this whole thing is like the transpose L plus 1 transpose multiplied by a vector of C Z1 L plus 1, etc., C Zn L plus 1. Okay, now this vector is actually directly related to this vector can be replaced by by this. For example, this value, this first value can be replaced, this whole vector, or this value can be replaced by over 0 1 L plus 1 times a 1 L plus 1 the 1 sorry z1 L plus 1. Now this is sigma prime derivative for the value 1 L plus 1, and this is our hero L plus 1 1. Okay, and then so yes, so this whole thing, now this value multiplied by this one, this actually vector, column vector, and this is a column vector, and multiplying these two guys together will give you that column vector. Okay, and this is a transpose matrix, and this is a transpose matrix, and we have finally, now we can obtain the errors of the previous layers from the errors of the latter layers, of the late layers. And this is what I just wanted to discuss with you. Really much interesting. And take care.